We are currently able to look back almost 13.8 billion years, which gets us extremely close to the Big Bang, the event that created the universe. Our understanding of the end of the universe has expanded, and despite science fiction and ancient writings often depicting apocalyptic events, the reality may be even stranger. What if the beginning and end of the universe are the same? The scientific community has been completely stunned by recent discoveries made by the James Webb Space Telescope, which suggest that the universe may have stopped expanding some time ago. This finding supports a prediction made by renowned scientist Brian Cox, offering new insights into the ultimate fate of the universe. We find evidence for what appears to be an event even more significant than the Big Bang itself. By studying light that began its journey before galaxies existed, we may be on the brink of another Big Bang. Join us as we explore James Webb's startling discovery that the universe may have stopped expanding, diving into this crucial finding regarding the origins of the universe. If there's one thing we know for sure, it's that the Big Bang is central to our existence. The scientific community agrees that the Big Bang signaled the beginning of our universe, despite the existence of competing ideas like eternal inflation or a bouncing universe. Nonetheless, the complexities of the Big Bang are often oversimplified. Even though it is widely accepted throughout popular culture, the Big Bang was much more than an explosion, despite the fact that people unfamiliar with astronomy may easily mistake it for one. During what is referred to as the inflationary epoch, it started as a phenomenon, an impossibly hot and dense point that rapidly expanded. The universe expanded in an unimaginable way when it was only 10 to the power of minus 34 seconds old, in less time than it took for a golf ball to grow from subatomic size. After this explosive beginning, the universe cooled and protons, neutrons, and electrons formed, among other elementary particles. Eventually, the atoms and matter that make up everything we see today were formed by the combination of these particles. The universe's expansion was underestimated for a long time. For instance, textbooks from the 1990s confidently stated that the universe was still expanding. The Hubble Space Telescope indisputably demonstrated that the universe was expanding and that it was doing so more rapidly. However, new data from the James Webb Space Telescope has challenged this perception. The scientific community has been shaken by these unexpected revelations, which suggest that the universe may have stopped growing. This discovery has significant implications and calls into question our fundamental understanding of cosmology. Is the universe no longer expanding, or have we always misunderstood this phenomenon? What implications does the universe's cessation of expansion hold for its future? While it is incorrect from a scientific standpoint, the creation of the universe is sometimes imagined as an explosion. NASA has clarified that, just as space did not exist before the Big Bang, the universe did not expand into it. Rather, the Big Bang signifies the universe's simultaneous birth of space. The universe was dark for the first 400 million years following the Big Bang. The cosmic dark ages ended with the formation of the first stars and galaxies, which illuminated the universe for the first time. On the other hand, our solar system did not develop until almost 9 billion years after the Big Bang. It is as exciting as it is unsettling to consider that the universe may not be expanding anymore. Until recently, scientists believed that dark energy was responsible for the universe's accelerated expansion. However, recent findings from the James Webb Space Telescope raise the possibility that this expansion has halted. This revelation could suggest that the cosmos is beginning to contract, a scenario known as a Big Crunch. An event of this kind could ultimately cause the universe to collapse, violently returning everything to its singularity of origin. This peculiar shift from an expanding universe to one that may be retracting raises many questions regarding the potential future of the universe. Although we have made great strides in understanding the universe, our technological capabilities are still limited, and we still have to deal with incomplete data. Even with complex instruments like the Hubble and James Webb Space Telescopes, cosmic microwave background, an echo of the Big Bang, is one of the discoveries that forms the basis of theories about the Big Bang and the expansion of the universe. However, technical limitations prevent us from directly observing events like the Big Bang. The possibility that the universe is no longer expanding is a sobering reminder of how much more research lies ahead of us, and how quickly new information can change our perception of the universe. Although the notion that the universe has stopped growing is disconcerting, it is not entirely unexpected. If there was sufficient energy in the universe, scientists have long speculated that it could collapse again. The findings of the James Webb Telescope point to a future where the universe contracts rather than expands, suggesting that this scenario may be closer than we previously believed. One thing is certain: our knowledge of the universe is continually expanding, and the universe may still have many surprises in store for us. This is true whether we are witnessing the beginning of the end or simply discovering a new chapter in the universe's life cycle. The most esteemed scientists at NASA thought they had solved the mystery of the universe's expansion during the 1990s. Their theory revolved around gravity as the ultimate force that governs the universe. However, what we now know is completely different from those initial ideas. At that time, astronomers predicted that the expansion of the universe would eventually slow down and lead to a massive Big Crunch. However, what if the energy density was insufficient to halt this expansion? The scientific community was plagued by this astonishing possibility. Nonetheless, their theories were merely educated guesses due to the lack of available technological resources. One thing they were sure of was that gravity would eventually stop the universe's expansion. It made sense at the time. The universe, being a dense region of matter, would remain intact under gravity's pull. Systems would cluster together, and gravitational force would counter the increasing distance between cosmic bodies. Up until 1998, when the Hubble Space Telescope challenged everything we thought to be true, this was the consensus among scientists. Hubble's mission was clear: to examine distant supernovae to track the expansion of the universe. However, what it revealed was something that no one had expected. The universe was expanding faster rather than slower. The scientists were stunned. This was not just a minor error. Rather, it was a discovery that required a radical revision of the fundamental assumptions of cosmology. It appeared that gravity, which was supposed to slow down the expansion, was powerless. A puzzling force was causing the universe to expand more rapidly. If gravity wasn't the cause, then the concept of dark energy, a mysterious, unseen force that makes the universe expand faster than ever, began to be discussed in scientific circles. Even while our understanding of dark energy is still rudimentary, what we do know is enough to challenge our assumptions. The universe consists of only 5% normal matter, which includes galaxies, stars, planets, and people. Dark energy and dark matter make up the rest. Even Einstein's cosmological constant, which he once considered his greatest blunder, was validated by this discovery. It turns out that the explanation for why the universe is expanding faster than ever may lie in this constant, which describes an intrinsic force within empty space. In the era of the James Webb Space Telescope, JWST, scientists are facing yet another startling discovery. There may be dark energy present in the universe, which would explain why it appears to have stopped expanding. According to the hypothesis, dark energy and gravity are engaged in a cosmic tug-of-war that will ultimately determine the fate of the universe. For a while, it seemed like dark energy was winning, causing galaxies to drift apart at an unprecedented speed.